Okay, welcome everyone to our workshop on leveraging nutrition data for secondary analysis. I'm Kelly Cara, a PhD candidate with the Tufts Friedman School of Nutrition Science and Policy, and I will be moderating today's session along with Ayane Ezaki. The session is being recorded for potential publishing on our symposium website, so please modify your name on Zoom and/or shut off your video if you do not want to be recorded. We do ask that all attendees keep their microphones muted until the audience question and answer period at the end of this session. Thank you. So this workshop is going to include 3 10-minute presentations, each followed by a brief moderator question and answer session. And after all 3 presentations have concluded, we will open up the audience Q&A. We don't want you to forget your questions along the way, so please enter them in the chat as we go and identify the speaker you want to address. You can write speaker 1, 2, and 3 or address them by name. We will refer to these during our final 10 to 15 minutes. Our presenters today are all from the Tufts Friedman School of Nutrition Science and Policy. And we will begin with Lara Castor, a PhD candidate in the Nutritional Epidemiology and Data Science program. Next will be Yutong Chen, who recently graduated with a master's in Nutrition Intervention, Communication, and Behavior Change. And the final presentation will be by Liang, a second-year master's student in the Nutrition Epidemiology and Data Science program. All right, so again, don't forget to put your questions in the chat and we'll get started with Lara.
Thank you for your presentation, Kelly. That was a very nice introduction. Good evening, everyone. I am very happy to be here with you today at the Tufts Research and Data Symposium. My workshop goal is to introduce you to the Global Dietary Database, which has been the main data source for my dissertation. So I'm going to walk you through the methodology that led to this data, and I'll introduce you to some examples of how this data has been used in the past and how it is currently used. The Global Dietary Database is an ongoing initiative that started over 10 years ago to leverage existing dietary data to create for the first time a comprehensive and standardized database. It includes 4 main aims. The first one is to quantify the dietary intakes of specific food groups. The second one is to quantify the disease burden that is attributable to diet or certain food groups. For instance, how many cardiovascular disease deaths can be attributed to the high consumption of sugar-sweetened beverages. Next is to disseminate this diet-related data through online platform and to publication. And finally, to use all of this data to inform policy. The first round of the GDD was the GDD 2010, and it included 21 dietary factors. The estimates were derived from 527 surveys. It included estimates for adults and included 2 time points, 1990 and 2010. More recently, there is a newer iteration, the GDD 2018, and this includes 30 more dietary factors. It includes over 1,200 surveys, includes now also estimates for children and adolescents, covering for about 99% of the global population. It now includes 7 time points, and in addition, it includes now information on education level and area of residency. These new features in the GDD will allow to further inform dietary risk and the disparities in populations and trends over time. The GDD 2018 built its methods and data on the GDD 2010. Quickly, I'm gonna walk you through the main methodology for generating this input data that went later into the modeling. So first is the prioritization of surveys, followed by online searches and communication with the data owners. Then a step of screening the surveys and ensuring that these met the inclusion criteria, followed by a step of data retrieval and assessment in which standardized protocols were created to identify, extract, and analyze this data. And finally, a standardization and harmonization of this data, which means to bring all this data to the same data structure and units so that it could be comparable. And of note, all of these steps included data integrity and quality checks during all the process. This led to the generation of the input data. This input data was then put into a model, and this generated finally the GDD estimates. So now let me talk you briefly about the input data. A recent publication from our team was released in 2020, and this publication includes all the characteristics of the input surveys. For instance, how many surveys were included, whether these surveys were nationally or subnationally representative, and whether these were from individual level dietary intakes or from household intakes. Now, in terms of the modeling, the GDD uses a Bayesian hierarchical prediction model to estimate the intakes. This type of modeling uses existing data to predict unobserved data. This modeling accounts for differences in the survey design, in the representativeness, in the dietary assessment methods, and in missingness. This model also allows to include an overdispersion parameter that accounts for variation due to survey level error. It also allows to include certain covariates. We included some survey level and country-specific covariates, such as food and nutrient availability, mostly from the Food and Agriculture Organization, food sales, economic indicators, and geographical data. The model generated means and 95 uncertainty intervals through Monte Carlo simulations. And finally, the model was validated using a 5-fold cross-validations and phase validity. This model then generated the GDD estimates for each country and year, and then jointly stratified by age, sex, education, and area of residency. And we created these for different foods, beverages, micronutrients, and macronutrients. And this is just a sample of the foods included. I can show you later where you can find the full list. Well, so how this model data looks like. This is a peek of how the data would look like. As you can see, we have here the data stratified by one single country, the USA, one single year. This is all for female, for one category of age, stratified by education level and urban area. And from here, for example, we could extract that in the US in 2018, women aged from 15 to 20 years old with a high education level living in urban areas had a sugar-sweetened beverage intake of 255 grams per day. Okay, so this type of data was created in GDD 2010, and that data allowed to quantify intakes and also to quantify the burdens attributable to the high intakes or low intakes. For instance, some of the foods that were quantified was sodium, and then it was quantified that 1.65 million of the cardiovascular disease deaths were attributed to high sodium intake globally. We also had some quantification for sugar-sweetened beverages and for omega-6 polyunsaturated fatty acids. So the idea now is to update these estimates and to also include the new information that we have now in other subgroup characteristics, such as education and area of residency. And my research has been focusing on sugar-sweetened beverages intake. These are some of the preliminary results that I have. In the map, you can see how the intake of sugar-sweetened beverages goes from 0 to 3 servings per day. The lowest intakes are the countries with the light yellow, and then the highest intakes are in the countries with the dark blue. We found that a mean global intake was higher in children and adolescents compared to adults. And then if we look at 25 most populated countries, we see that the highest intakes were found in Mexico for both children and adolescents and adults, and the lowest were found in India. Now, as I mentioned before, this data also has information on this intakes. The estimates are stratified also by education level and area of residency. And in this map, you can see in the x-axis, you have the education level, low, medium, and high, and it's so stratified in rural area of residency and urban area of residency. In the y-axis, you have the sugar-sweetened beverage intake, and each of these boxes corresponds to one different world region. So for example, in the bottom, we have the sub-Saharan African region, And here we can see that the intakes appear to be a little bit higher in the medium and high categories of education in urban areas versus rural areas. There is a similar trend for the South Asia region, and there appears not to be such a trend in the rest of the regions. So this is something that needs further exploration. Something else that we've been looking at is the absolute change of the sugar-sweetened beverages intake from 1990 to 2018, with a midpoint of 2005. And here in this graph, you can see the time difference. In the bottom, we have 1990 to 2005, 2005 to 2018, and then overall from 1990 to 2018. In the y-intake, you have in the y-axis, you have the absolute change. And you can see how from 1990 to 2005, there was an overall increase in all the regions of the world. There was, from 2005 to 2008, there was an increase in most of the regions except for the Central Eastern Europe and Central Asia. And overall, we have an increase in most of the regions except of this one. So the next steps for my dissertation include to quantify now what's the cardiometabolic disease burden that is attributable to this high intake of SSBs. And now, as I mentioned before, one of the aims of the Global Dietary Database is to provide all of this data publicly available. So you can go to the website, the Global Dietary Database, and download this data. We have the model data, which could be the one that it's gone through the modeling and it generated the stratified intakes. And there is also the data that it's the input data that was the original survey that was collected from the public service or collected from communication with the data owners. And with this, I just want to acknowledge my thesis committee members, the Global Dietary Database team, and the funding sources. Without any of them, any of this work would have been possible. Thank you.
All right, thank you, Lara. Since this session is focused on a workshop, I wonder if you could take us through the GDD website just to show us how we can access data and how you determined which data points you might want to focus on.
Yeah, sure. So let me see if you can see my screen. I have the website. Can you see the website now?
Yes. Yeah.
Okay, perfect. So this is the website. The first time you come into the website, it's going to ask you to create an account. I created mine already, so that's all set. And here you can learn more about the team. You can learn more about the work that has been done. Can learn more about the methodologies. All of these methodologies that I recently explained, it's also explaining here in a little bit more detail. And here we have the data. So this is the data that I was talking about. So these are some of this is the model data. So you click in here, and this is all of the factors, the dietary factors that are available. As I mentioned before, I'm focusing on sugar-sweetened beverages, but you can look at all of these. Then you have to agree to the terms and then download this data. And yeah, so it takes a little bit of to download the data, but basically you can just use any software that you usually use and then just clean it. Not clean, sorry, it's clean already. Just look at the data, and you can always contact us if you have any questions. So that's for that data, and there is also the original survey. So you can also download the original dietary survey, which this again, it's the data that was collected through communication with data owners or through online searches, and it was publicly available, and this data was downloaded and then cleaned and everything, and then uploaded into this website. So here you have all of that data, and you can filter by specific characteristics. And for instance, let's go to this one, the first one here, and then you can get access to the data. We have the participant data. It's split generally in two: the participant data, the dietary data, and we have a codebook, which it's very, very specific. I didn't mention this before, but there is a third type of data that we have. It's just more granular data that we worked the past 3 years to create the most granular possible data. And this has also been coded to FoodX2 code. So this is just to ensure even more comparability across data sets. And for example, this data set includes that type of granularity. So if you are curious, you can come and see. And then we have like some information here about each survey. You can see the year, the country, what type of dietary setting method was used, and the type of all of the dietary factors that were included.
Great. I noticed you had a lot of really lovely visualizations. Are those things that you created separately, or can you create them through the GDD website?
That's a great question. No, those are visualizations that I create separately. Yeah.
Okay,
yeah,
so
yes.
So for students that want to use this data in their projects, really it's about identifying variables they'd be interested in, downloading a data set, reviewing the data dictionary, and then creating visualizations separately.
Yes, exactly.
Okay, great. And you mentioned that this is a publicly available data set, but are there any permissions that students need, or can you direct us to any citations that students would be need to be aware of?
Yeah. Every time you download some data, it pops out some citation that you are encouraged to use. Yeah, but other than that, it's publicly available and everyone is free to. Everyone can use this data.
Okay, great. Thank you so much. There is a question in the chat if you want to address it, but we can also get to that during our Q&A. So again, everyone, please remember you can share questions in the chat as we go. We will move on to Yutong next for her presentation.
Let me share my screen. Hi, everyone. My name is Yutong, and I'm really glad to be here to talk about my study. Okay, so my study is testing the agreements in dietary intakes in international databases, comparison of the global dietary database and the global burden disease database from 1990 to 2018 using Bland-Altman plots. So this is one of the case studies in the GHNA program, which Echo will introduce you what is GHNA program is just in a few minutes. So the goal of this workshop is to first show you how to interpret the Bland-Altman plots, and second, to present examples of the BA plots. And the third is to show how to use them on your own research. So a little bit background of this study. Initially, I want to compare the global dietary patterns with the Eat Lengthen diet, which you might already heard about this diet before. It is a plant-based diet and tries to link the diet with human health and environmental sustainability. However, I found that there are some discrepancies between the dietary databases. So I decided to start this case study. And there are two goals of this study. So first is to compare the discrepancies of GDD and Gpd, since they are the two most extensive and comprehensive databases offering national estimates for dietary intakes of major food groups and micronutrients. And second is to explore the degree of agreement in relation to the reference levels, which represent sustainability and public health nutrition. Since Lara has already introduced GDD, I like to just simply introduce the Gpd data set. So here is the screenshot of the website called Food System Dashboard. And it is an interactive dashboard developed by the Gpd team. And it contains 7 dimensions of nutrition data and health data like shown here. And also you can see on the top bar here on their website. And there are some differences between the GDD and Gpd. So GDD has 54 dietary factors, but Gpd developed the database based on the 15 dietary risk factors. Both of them have data in global, super region, and country level, but GDD contains more granular level data than Gpd. So, and also GDD generates the estimations in every 5 years, but Gpd's data are in every 10 years. Both data sets use their own data sources, methods, and models to generate the estimations, which GDD use Bayesian and Gpd use the Gaussian process regression. So the method I use in this study After comparing the food groups in both data sets, I identified 13 food groups that are present in both GDD and GPD for the data intakes in 1990, 2000, 2010, and 2018 for 184 countries. And here, the 2017 GPD's data is used to compare with the 2018 GDD's data. I also explore the degree of agreement in relation to the recommended threshold in this study, which including the Eat Listen diet, the 2025 dietary guidance for Americans, and the estimated average requirement. And the methodology I use in this study is scatter plot and the blend outman plot for to facilitate the visual comparison. And here, let me explain what blend outman plot first. It is commonly used in biomedical fields for investigating the degree of agreement between two measurements. Most of the time, it is used for analyzing the difference between two assays or two methods. So in the BA plot, the x-axis here is the average of two data sets, which in this study is the mean of GDD and GPD value. And the y-axis is the difference between two data sets, which in this study is equals to GDD value minus GPD value. So let's see if the two data sets are completely same, then all the points should be laid down on the y=0 line here. And the major benefit of using the blend outman plot is that it can reveal both systematic and random errors clearly, which I will explain in the next few slides. So before moving on, there is one point needs to be emphasized. So BA plot can only imply whether there are discrepancies between the two data sets, but it is not necessarily represent that like which one is better. Let's talk about a few scenarios. So scenario A is fruits. And let's see here, this is the blend outman plot. So the pink area here represents the 1 standard deviation and 2 standard deviation of the mean difference of GDD and GPD. And here, this red line here represents the global mean difference of fruits. And the gradient blue color dots here represents like the 4 different years. So you can see in the scatter plot that the two data sets are overall statistically similar. And so it shows an overall agreement in the 45-degree here position in the blend outman plots. And also in these blend outman plots, so almost all the dots are distributed evenly within 2 standard deviation of the mean difference. It means that the GDD's estimation are consistent with GPD's estimation. So this is scenario A. And scenario B is unprocessed meat. So they exhibit systematic difference. So in both scatter plots and the BA plot here, you can see they have like a strong positive correlations between the GDD and GPD. And plus, in the blend outman plots here, so most of the countries are above the y=0 line, the red line here. This is demonstrate that the GDD's estimation are overall greater than the GPD's estimation. And the discrepancies between the two data sets are significant, but systematically similar. As well, you compare with the scatter plot here, you can see overall the GDD's number is greater than the GPD's number. And here, scenario C. So this one is sodium. And in the BA plots, you can clearly see that there are some outliers and clusters here. So especially in specific countries and years. Like for example, here, the right circle here represents China's sodium consumption between 1990 and 2018. So we can see that GPD estimates the assumption is about 10 grams per day. for China, and then the GDD estimations is about like 7.5 gram per day. So in the BA plot, the average here is around like 8 gram per day, and then the difference here is around like 5 gram per day. And same with the Lao People's Demographic Republic, and this is like a different from scenario A because like we can see there are some influential outliers or clusters here in this scenario. And the last part is to compare with the recommended threshold. Like for example, in fruits, here this is a blend ultimate plot, and you can see the green line in middle that represents the recommendations of the eat less than diet. And the dashed green line, so in between on the left and on the right, they represent the range that given by the eat less than suggested amount. And when we compare with the estimations of the countries, we can see that most of the about like half of the countries are below the lower line, and then only a few countries like reaches the recommendations by the eat less than diet. And same as the unprocessed meat here, but the difference is that most of the countries are above the higher end of the eat less than diet. And for the sodium here, so this is there's only one green line here. It is represents the DGE value, the 2.3 gram per day. So we can see that almost all the countries are over 2.3 gram per day. So in conclusion, the data demonstrate that unnegotiable gaps exist in some food groups' consumptions. And like in the future, we need to understand what causes those inconsistencies and how can we like minimize the gaps. So this is all I have. And then I really want to acknowledge to the GHNA team and the GDD team, and also thanks for the Gpd database, like which offers a lot of support for my study. And thank you for listening.
All right, thank you, Yutong. So similar to Lara, I'd love it if you could walk us through briefly the Global Burden Disease website. And just so everyone in the symposium knows, we will be putting relevant links in the chat, so you can also follow along if you want as we look through these databases.
Sure. So I can share my screen. So here, so once you click on the website that Ayane shared in the chat, you will open this food system dashboard. So this is an interactive dashboard that created by the Gpd team. And then once you're, for example, click either on the compare and analysis or the country profiles. So the compare and analysis, it will show you like how the map looks like, and then how the indicators change over years. So they use the like a world map to show like how the things has been changed. And if you click on the country profiles here, it will show you the data actually. So it will bring up a bunch of charts, and then those charts cover the 6 dimensions: the deliveries, food supply chain, food environment, individual factors, consumer behavior, diet and nutrition. So diet and nutrition are the data set that I have been used. And then, for example, if you just want to download like a single data visualization or a single plot here, you just click on the download bar next to the plots, and then this plot will be downloaded. But if you want to download the, for example, the entire data set, like cover all those 6 dimensions, like there is a download data set button here. You just click on it, and then it will download the data. So, and if you click here, so the word, like the one I selected is the word, but you can also select like different countries and then different super regions. So for example, let's choose Canada. And then if you click on it, and then you click the download data set here, it will only download the data for Canada itself. And same with the super regions and the world. So this data set is completely public, and then you don't need to register a account to get access to the data. And I think they are available for using for the publication.
Yeah, I was wondering about that as well here. If you end up downloading these visualizations, I assume that you'll need to provide a citation in your manuscript or in your paper. Do you know if the citations are easy to find, or could you direct us to those if you're?
Yeah, so because this is the dashboard created by the GPD database. So if you just search GPD database in Google, it will like bring you to the GPD data set, like the website itself, and then it has a like a branch of it is logging, but it has a branch of introduction there, like what countries they cover, and then like what data they are available there, and then the how they use the model to estimate all those data. So all the information are in the GHDX website.
That's very helpful. Thank you. Because I know a lot of when we do like a data analysis plan, you've got to include all that information. Where did these data come from? How are they accumulated? So, all right. Thank you so much. And again, for everyone, we'll be going to the audience questions at the end. So please keep them coming. These are great questions that are coming in. All right, let's switch over to Echo for our final presentation.
Yep. Hi, everyone. Let me just share my screen. Oh. Perfect. So hi, everybody. My name is Echo. I'm a second-year master's student in the Nutrition Epi and Data Science program here at Tufts Friedman School. Today, I'm going to present a case study of rearranging nutrition data for secondary analysis. And my case study is about evaluating the association between the cost of nutritious diets and nutrition adequacy. So today for my workshop, my goal is to first introduce the Global Nutrition and Health Atlas, GNHA. Second, to introduce my project of the secondary nutrition data analysis. And three, showcase how to utilize the GNHA visualization platform to form your own research question. First of all, I want to introduce the GNHA, which is Global Nutrition and Health Atlas. It's powered by Friedman School of Nutrition Science at Tufts University and also Nestle Research. The GNHA is a public online platform that provides data portal and interactive visualizations dashboard to present a diet-related health information, including demographic, socioeconomic, nutrition, and health-related data for more than 190 countries. So all these data are collecting from multiple public sources, including NGOs, academic institutes, international agency, and also individual research paper, who are aiming to support multiple stakeholders seeking dietary health information at global, regional, and national levels. So the GNHA covers 6 dimensions. You can see in the front of my slides, in the left of my slides, the schema shows the structure of the GNHA data. It covers 6 dimensions, 26 themes, and more than 500 indicators, covering more than 1 million observations of all perspectives of global nutrition and health. So on the right of my slides is an example of our data visualization dashboard we have for each theme. So here is the example for the theme demographic. You can see demographics is under the topic demographic. So this dashboard provides an overview of the global population data. The dashboard contains 2 tabs. You can see global demographic here and also country profile. Demonstrating the population data about age, gender, fertility, mortality at the international and national level, respectively. Country profile is presented as an individual 1-page infographic for more than 190 countries in the world, which gives a user a quick demographic outline of a specific country, which means you can customize the visualization to the country you are interested in. So here I took a screenshot of the tab of global demographic. This is an integrative visualization that contains various types of maps and charts. I'm sorry, I can only screenshot the the first half of the page, and I can showcase if there is time at the end of my presentation to really go into the dashboards. But we can see in the dashboard, there are different type of mapping charts like histogram, bar charts, and time trends analysis. So in terms of download, except data visualization, the GHNA have another function, which is data portal. That is a summary in terms of the structure of the data portal of a website. You can see from data exploration, which is one of the main function. We are planning to build, like we have a Tableau dashboards, which is designed to be as flexible as possible with as many as option of mixing, matching, and subsetting the data, which I will showcase at the end. Is a dashboard that you can screen and subset the data and have a preview look. We also have a data repository, which the users can customize the data, view the availability of data, download the data, and access the data metadata information. So here is, I'm going to talk about my project. So my project is about evaluating the association between cost of a nutrition diet and nutrition adequacy. Given overlook, this is a poster I make for the Consortium of University of Global Health. And I can introduce step by step every section. First, I will talk about why is this research so important, because research comparing relationship between economics indicator and dietary intake on a country level are very limited. Most analyses are only focused on individual level survey, and nutrition disparities is causing malnutrition and overweight around the globe. Double burden of nutrition in lower and middle income countries and obesity in high income countries are concentrated among the poor. And we also find out that according to literature review, food price can also be a critical determinator of food choice. Accessibility to diverse foods and a healthy diet can be monitored by food price. I have two specific aims. First, measure the weighted population level dietary intakes, nutrient intakes for 8 nutrients: carbohydrate, protein, iron, magnesium, vitamin C, zinc, calcium, and folate, and for 8 different sex and age groups in 161 countries. Second, expose the strand of relationship between cost of diets, cost of nutrition adequacy diets specifically, and 3 nutrition outcomes, which is that daily nutrient intake, untruncated nutrient adequacy ratio, and nutrient adequacy status, which is a binary outcome. You can see this is a cross-sectional secondary data analysis, and most of the data used in my case study, I'm sorry, skipping, can be found in the GHNA database. So I used the population level dietary intake data, which is originally from the global dietary database. I have used the cost of nutrient adequacy diet, which is from a publication from a World Bank economics. And also I have utilized the food expenditure per capita, which is from the international comparison program from the World Bank, and also country income level classification for the United Nations. Talking about model selections, I have 3 different models here using like either of them are like unit variable and multivariable with mixed effects and also covariates. So talking about selection of covariates, I have incorporated country income level and daily food expenditure per capita and PPP US dollar in 2017. So talking about the results, the global population weighted daily main intakes were 267 gram, 76.4 gram, 295 milligram, 13.1 milligram, 96 milligram, 8.46 milligrams, 661 milligram, 279 milligrams for carbohydrates, protein, magnesium, iron, vitamin C, calcium, and folate, respectively. And we can also see, according to the p-value here, the daily main intakes very varied by country income. All three models from this fluster plot, we can see all three models show significant reductions in weighted daily nutrients intakes and untruncated nutrient adequacy ratio, which is the outcome A and B for magnesium, iron, vitamin C, zinc, and calcium with higher costs, which is mean if you have higher costs, you have basically less, like a smaller income intake for these nutrients, calcium, irons, zinc, vitamin C, and magnesium. And for protein, model 1 and 2 showed significant reduction in weighted daily nutrient intakes and untruncated nutrient adequacy ratio with higher diet costs. But for nutrient adequacy status, all three models indicate significant increase of odds of having nutrient deficiency on zinc and magnesium with increasing cost of nutrient adequacy diets. So this study gives us an overview of population stratified nutrient adequacy status for 8 nutrients for more than 160 countries in the world. We also find that increased nutritious diet cost is associated with higher intake of carbohydrate and poor in nutrition adequacy status in other essential nutrients, leading to lower dietary quality. The cost of our nutritious diets may be used as nutrition sensitivity indicator, providing evidence for policymakers to guide agriculture, food, and nutrition intervention to the policy. So I just want to say thank you, and I want to lead a question to the audience. So in a few minutes, I will showcase how to utilize the GHNA dashboard and visualization to form your research question.
Yes, thank you, Echo. And I'd also like to just break in and add that in the chat, we will be able to dive a little more deeply into the GNHA tomorrow with a session led by Bing Jijo. Go ahead.
Yeah, definitely. So here is the GHNA website, and I just want to show mainly two parts of the GHNA section to our audience today. So first, you can see there is a dashboard gallery here for 6 themes I just mentioned in the data structure. Both of them, we have a different dashboard, like a visualization dashboard in Tableau. So yeah, so for example, for each theme, this is for the theme dietary intake. We have a global overview, which we have multiple different kind of histogram bar charts and ranking charts. And we also have a country profile, which you can choose a country you're interested in and have the different variables visualized here. And the second part I want to show from the dashboard gallery is about global, it's called global comparison dashboard. So for my own case, I started my current project from the GHNA as a case study. And for example, I can make and I can customize scatter plot by choosing different variable in x-axis and y-axis. For example, I can choose food and select a theme and food and nutrient daily intake and select the indicators I'm interested in. For example, like by here's our all the daily intake are from global dietary database, like I said. And for the Y theme, we can choose the outcome variable that we're interested in. For example, for disease burden, I can see, like, for example, the DALYs lose due to all courses according to different food intake. So that's very interesting, because when you are viewing this nutrition data from multiple data sources, you're able to utilize this tool to kind of form your hypothesis in your research question. Outside than that, I also want to introduce the data exploratory, which is also a Tableau dashboard, and you can choose the theme you're interested in and the indicators you're interested in to have a subset data set. And also in the data portal, is there also a chance for you to have visit the data repository, which you can download all this data. So here it is. So, and I just feel free to have any questions and like regarding to the GHNA and also of my projects. And thank you so much for my presentation.
All right, thank you, Echo. We're going to open it up now for audience questions. Again, you'll be on mute, but you can please put your questions in the chat and we'll moderate them. So the first question that we had come in was for Lara. Our GDD 2018 beta estimates. Are the data provided, are they beta estimates?
Yeah, so these are supposed to be the final estimates. I know that there is some updates going on this month, so I could wait. You could use this data to start working on it, and maybe just download the data again by the end of the month. And you can send me an email if you want. I think we're gonna be, I mean, the people who are uploading that would be uploading some message about it, but you can also email us just to make sure those are the final estimates. But that should be done by the end of this month. But in the meantime, you can start working with the data that it's there to start getting the idea of. And it's not going to be very, very different. So even like working on the discussion and conclusion shouldn't be too different afterwards.
Great. And the follow-up question was, I think, kind of answered in your presentation, but can you use it for publication, the current GDD 2018 data?
Yeah, so the same, it's just every time that you download the data, it's gonna show you what's the preferred citation. So as long as you cite appropriately the data, that should be fine. And again, I would just wait until the end of the month to have the final estimates.
Great, thank you. The next question is for Yutong. Were all the dietary information recorded the same way across countries? And if not, how did you take that into consideration when analyzing the data set?
Yeah, the data set structure is very similar to GDDs. So what they do is just like every country's structure is same, and then they put like every country's data in the most granular level they have in the data set. So I can quickly share a screen. So this is for calcium, and then this is how the data set looks like. It's very similar to GDD, so the time period here, and then the data value here, and then they have like the age group. So it's either adults or later on they have like for children. Yep, and then in some data set they have like granular level by age and the sex.
Okay, and the next question is also for you, Yutong. I believe this is in reference to your own project in the Bland-Altman plots that you included. Have you used the estimates or the original data from the GDD in producing your work?
So the original data from GDD, is that mean the raw data from GDD?
This is Ayane. She may have meant GBD. I'm not sure. Yeah. So
yeah, maybe she was referring to the two types of data that I mentioned in the GDD, that we have the raw data and the estimates. I don't know if Ayane, you want to clarify your question.
Yeah. And maybe we can approach this way. So you all have some very interesting dashboards and there's tons of data to choose from. How do you decide which data you're going to focus on? Are there, we have several different databases being brought together in the GNHA, for instance. How do you kind of decide what you're going to focus on? Anyone can answer that one.
Sure. Maybe I can go first. So for mine, because I want to compare the estimations from like different data sets. So that's the reason why I choose the GDD and GBD, those two databases, because they are the two largest dietary database in the world. And then because like GPD make the estimations is through the dietary factors, so it's different from the GDD model. And then I have to identify which group I can compare in my study. So like eventually there are only 13 of them can be compared. And then that's how I come up with my study. Yep.
I can talk about my project. So I started to develop my project as a case study of GHNA. So basically, I'm very interested in how those nutrients intake data vary in different countries. And as we know, GDD is the only ones that have the country level nutrients, either macro and micronutrients intake. So I studied from that. And as an outcome, I'm wondering, because I'm also very interested in the burden of disease. So when I'm looking to the burden of disease in nutrient deficiency, and I kind of form a hypothesis that probably their nutrients intakes and their prevalence of nutrients deficiency may be a very interesting question. And adding the cost of diets as in other very fun indicators in terms of economics effects of dietary intake. So that is how I form my research question, but I find it very helpful to use the scatter plot, the customized comparison scatter plot I just showed every one of you as like an experiment to hypothesis or to form a research question.
Yeah, and for me, Kelly, I guess for me it was a little bit of I started off in this team when I started school, but before then I was interested in diets and association with cardiovascular disease. So that's how I found out about this team, and that's how I joined. So eventually I focused my research on sugar sweetened beverages.
Nice. Just another question from a student's perspective. If you're in the master's program or in the PhD program, but especially I think for master's students, do you have any tips for getting started on a project like this? There's so much data and there's not a lot of time during a master's program, especially. Are you going to these databases on your own first? Are you speaking with faculty first? If any of you could just kind of touch on that.
Yeah, for the global dietary database, I can say that if any of you is interested, you can reach out to any of the team, and then we would be happy to walk you through it. But there is a lot of documentation out there. There is a lot of publications that have, well, from the past iteration, but basically, as I mentioned before, it's the new iteration builds in the past methodology, so it should be pretty straightforward. And there is also new publications that have just came out a few months ago and that are coming up. So I would start with the websites and the publications, and if you still have questions, feel free to reach out.
Yeah, I just want to share my personal experience. So I would say I highly recommend we leverage this nutrition data in our courses. So when I'm taking the biostatistics and also and there is another courses in data visualization here in Friedman School of Nutrition, and I can utilize, and there is a trend for us to do to build our own projects or their course projects. And I think during that time, it's a great chance for us. Probably the professor, the lecturer will provide example data, but there is a lot of chance for us to choose our own data. So I highly recommend we utilize the chance in these courses to use like a real world data in analyzing nutrition outcome. So yeah.
Yeah, great suggestion.
Yeah, and for my case, because I was interested in the sustainable diet first, so I was trying to compare the GDD data set because I only know that one at that time with the Elanson diet. And then I talked with Elena, who is my supervisor. And then once we start to develop this case study, we found there are discrepancies between different dietary databases. And then we decided to, okay, add another part, like to find how large the discrepancies, like between the databases like in my study. Yep, and then another suggestion I will have is that, so if you are interested in using one database, probably, I know the database is really large, but get familiar with the structure of the data, which may be helpful for you to see, okay, so I can maybe use this data compare with that one. So it can be helpful in that way. Yeah.
Great. Well, thank you all. I'm going to go ahead and wrap up for today's session so you have time if you need a break before the last session, which we'd love to invite you to attend. This one is specifically geared toward career talks for agriculture, food, and environment students, or anyone interested in those careers. So please take a look, but also remember tomorrow, if you want to dive a little more deeply into especially the GHNA database that was shared today, there's a session tomorrow. And again, that information's in the chat. So thank you all so much for attending and enjoy the rest of the symposium.
Thank you, everyone.
Thank you. Bye. Oh, hi, Elena.
Oh, Elena.
Oh, probably Elena cannot unmute herself, so she cannot speak.
Maybe you can unmute yourself now. I think I just fixed it.
Great, thank you very much. It was wonderful, wonderful sessions, and thank you for bringing all this very important question. Especially like Kelly, your questions in terms of helping, students to find interesting research project. I think this is so valuable for all of us. Thank you, and see you soon on the next session. Bye-bye.
Thanks, Elena.
Bye.
Bye.
Thanks, Kelly, and again for your great guidance on this.
Yeah, thank you, Kelly.
Yeah, teamwork. Ayane, you kept it going. Great job.
Okay.
Yeah, let's wait a minute before debriefing.
Sure. Yeah, I think we lost echo.
I'm gonna go, guys. Bye.
Bye.
Bye.